Hello teacher, hello guys. My name is Juan Pablo Marin. I apologize if it's not the expected but it's my only form that I can record this video. So I am talking about the exercise in front of my screen, and I show my screen and talk during the explication, but the camera is focused on my screen, not in in my face. This video is for recuperation midterm exam. My name is again Juan Pablo Marin. Okay, first I read the exercise. A torque T is applied to shaft AFG, which rotates at constant speed and constant GRF. GRF transmits torque to shaft ABCD via GRC, which drives chain sprocket B, transmitting a force P. This is a force P. Okay, as shown in the figure and the image. This is the image. Chain sprocket B. This is the sprocket B. And GRC is this half pitch diameters A and B. The diameters are different. Okay, and C, that is this, is respectively assume not friction losses and considering the brings at A, D, E, and G to be simple supports. That is simple support, no more. Additional consider that the contact force between gears F and G transmit throughout the pressure angle. I don't know what sig is, but this producing tangential and normal components that can be calculated. Okay. I need a response these five or that five's question. The first is state the geometry parameters necessary to solve this problem. Use reasonable values that will allow you to arrive at the solution. It is expected that each person will obtain a different solution. B is obtain the free body diagrams for axis ABCD and calculate the force reactions and torsional moments on the axis. The C is calculate the location and magnitude on axis ABCD of the maximum normal and shear stress produced by bending. It's very important, by bending. D is calculate the location and magnitude on axis ABCD of the maximum shear stress due to torsion. Is different. The difference between these two questions is one is for bending and the other one is for torsion. And the last one is E. Combine the maximum normal and shear stress obtained in C and D. Calculate the location and magnitude of the maximum principal shear and normal stress on the axis. This question, the answer is for the formula more. For response, the first question, I have these datas or those datas that I choose. A is 100, B is 200, 6 100 again, D is 40 millimeters. Obviously, all data is in millimeters. A, F, and G is the length between two different points. For example, the length between A and B is 100. The length between BC is 300, obviously millimeters, and G is the length between C and D, again 100. The length total, or the total length, is the 500 millimeters, and the torque Okay, and the last one is the angle between the contact between um, two different GR, the GRC and the GRA. Yes, I think. Yeah, between this and this. Okay, the first step is done, is very done, and then I need to obtain the free body diagram. Okay, this is the free body diagram. I have the length, the total length in meters. I have two different reactions in different axes. In my case, I use the reaction in axis X and G in reaction 1 and reaction 2. I have or okay, we have two different force. I calculate this different force with this form. F F TC is the tangential force is 200, and FNC is normal force, that is 72.79. That is okay. Okay, now let's make use the sum of strength in the two different axes for obtain reaction and forces. So this is the equations, and the I can now reaction dg is 240, and re ag is through 360, and the same for the axis x. So the reaction is this and this. Okay, with help in internet I can get these diagrams, that is shear diagram and moments diagram, in my beam. Okay, so I can know the stress producing by bending, that is moment, maximum moment, that is this. um, Sigma f is this, and the last one is torch is this. Okay, the last one, the last page, this is for answer the the B, no, the C answer, the C question, and this is the question. The torsional stress that is calculated from the properties geometrics on of the axis, and the torsional shear stress in my beam is this. And the last one, I use the Morse formula for calculating the maximum stress, and the sigma 1, sigma 2. Sigma 1 is from this equation, that is this. Sigma 2 is this question, is the same but different. In one is sum, and the sigma 2 is this, and the torsional max is this. Okay, thank you.